Good morning, campers. My name is Scott Singleton. I'm with the Houston Gem and Mineral Society, and this presentation is in cooperation with the paleontology section of that society. So my presentation today is an introductory lesson on how to quickly identify some of the petrified woods that you might pick up in this part of Texas. This is not meant to be an exhaustive presentation, but just an introductory one to introduce you to the concepts that would allow you to preliminarily identify things that you pick up. So the first thing we need to do is review our wood anatomy that we all learned a long time ago in school, or maybe some of you are currently in school. So let's review these terms. What we're looking at is the interior of a tree. This wood is known as secondary xylem. That's the entire interior portion of the tree. That's separated from the outer portion, the bark right here, which is separated from the secondary xylem by a layer of phloem and cambium. And you see those identified here as well. Now those terms are important because cambium is the way that all flowering trees, angiosperms they're called, it's the way they reproduce cells. So they grow cells in the cambium, and that's how a tree expands in diameter. And one thing that you need to remember is that there is an annual amount of growth that the tree has. And the annual growth is known as a growth ring. The late wood is the winter growth, and the early wood is the spring growth. And you can see that here. This tree, because you can identify the growth rings, you can tell that early in its life, it grew quickly. And later in its life, it grew really slow due to some kind of environmental reason. We don't know why right now. Might have been because there was a fire. You see this dark ring right here that usually is a burn scar. But you can see the late wood right here, this dark, and that's the winter growth, which isn't that much. And then you can see the spring and summer growth, which is the light colored. That's the thicker portion. So another thing that we need to keep in mind is these features here, these radial lines that go from the center all the way out to the edge. They are known as rays. That is an important cellular feature that we will use for our identification. Okay, so right now we're going to go into one type of angiosperms or flowering trees, and this is what's known as the softwoods, and those are all conifers. Now the reason they're known as softwoods is because their wood is not very dense. It's light, relatively light, and so they call them softwoods. And those trees, conifers, you don't really see a whole lot if you're looking at just a macroscopic view, say with your eye, or maybe even a 10x hand lens. Main thing you see are these lines right here, which are growth rings, as we previously identified or defined. And growth rings can be seen a little bit clearer if you take a chunk out and blow up that chunk. This is with a microscope, and you see just an irregular array of cells, and then you see the growth ring. It's very clear. You can see that growth ring very prominently. And even magnifying this image, a cross-section image, further, we see that these cells are all lined up on top of each other. They're in these radial chains of cells. These cells, by the way, are known as tracheids, and that's mostly what conifer wood exhibits. This here is a resin vessel, and we don't see these in the fossil record here in Texas, but they do occur. For instance, pines. All pine trees have resin vessels. We don't have any fossil representatives of pine trees, so we don't have those in the record. All we have is these tracheids, and you see their configuration lined up one after another as they grow radially outwards. Okay, so right here we have 3 examples of fossil woods that I've collected, and I'm showing magnified. And you see the magnifications here listed on the bottom. These 2 right here are 50x. So that's 5 times the amount of magnification you'll see in a 10x hand lens. And this one right here is nearly 80x. So at the 50x, you see prominently one major feature, and that is every time there's a growth ring, you see the indications of it in these sections. If you blow this up even further into this one right here, you can see the growth ring right there, and you also see the regular array of tracheids building one right after another in columns from the center to the outside of the tree. You also see a second kind of cell. It's these dark things here. These dark cells are a second kind of cell that you can see if you have magnification, and they're known as parenchyma cells. Those are storage cells. They store resin, they store starches, they store other kinds of food. I'll identify and define parenchyma cells later when we start talking about hardwoods. Here I have a very nice looking specimen. It's a slab. And in this slab, the first thing you can notice is this dark ring all around it. That's a mineralization ring, and it's common in one of the formations here we have in Texas, known as the Eocene-Yewa Formation. But the reason I'm showing you this specimen is because you can start to note a couple of distinct characteristics in here, and those characteristics that I want to point out are these lines, these concentric lines that go all the way through this specimen. And as I start getting closer and closer and closer, you can see that those lines all are regular, and what they are, those are growth rings. And as I was just describing, growth rings, prominent growth rings like that, are distinctive of conifers that we have here in Texas. And so that's what this specimen is. It's a conifer. Okay, so now we're going to leave the softwoods or the conifers, and we're going to go to hardwoods, which are most of the common types of flowering trees that we have nowadays. These are more recent evolution, and they arose in the Cretaceous, in the latter part of the dinosaur age, and so their cellular structures has a lot more features in there. So let's go over some of these. So we have late wood and early wood. But in this particular case, the early wood is characterized by large vessels. And this is because early in the growing season, there's a lot of water demand when the tree leaves out. It needs a lot of water coming up from the roots, so it makes these large vessels here. In the late wood portion, what we have is small vessels because there's less water demand. And so you have smaller vessels. The ray structure here is unique in that we have some thick rays that are called multiseriate rays. They're thick because they have multiple columns of ray cells. And then you have thin uniseriate rays that are here. You can barely see these vertical lines here. Those are thin rays, and you almost can't see those even with a hand lens. So we tend not to worry about it. The identifying feature here is the thick rays right here. Now we have a couple different kinds of cells. We have what's called fiber cells, which are the background cells between the early wood rays, early wood vessels, I mean. And then we have parenchyma cells and tracheids that are right here surrounding these vessels. So you notice these are lighter colored, and we have some parenchyma cells surrounding these. When I discuss parenchyma cells, you'll remember that we talked about halos around vessels being due to parenchyma cells.
Hi, now I'm showing you another nice looking slab. And this one has some different characteristics than the previous slab I showed. So the first thing you can notice is these dark streaks. That's mineralization. And you can also notice some brownish areas there with holes, and that's where there was degradation, decomposition of the tree, the trunk, before it fossilized. And you can of course notice on the outside, this is pretty rough. This trunk had some erosion, weathering before we found it, liberated it, and slabbed it. So now we want to try to figure out what this is. And you can see several characteristics, again, very key characteristics as I get closer and closer here. So what you see, the most prominent thing you see in this one is these lines, radial lines going out from the center all the way to the outer edges. And this you should recognize as a ray, a whole series of rays, and they're very prominent, like in the example I just showed in the previous slide. So when we get closer and closer to this, you can start to pick out more detail with these rays. So you see that between the rays, so there's the ray right there, and there's the next ray. Between the rays, you have several lightish sort of streaks between each ray. And if you remember from the previous picture that I showed, these streaks are the sort of flames of vessels, small vessels, and parenchyma cells that form in a live oak. So this is very distinctive. Live oaks are about the easiest thing that you'll ever have a chance to identify, and that's what this is. It's common in the Miocene, the Oligocene and Miocene of Texas.
So in the previous example, you saw that we had a couple of different kinds of vessels. We had small ones that were all strung together, and we had large ones near the growth ring boundary. So let's review the different types of vessel configurations that you can see, since rays and vessels are two of the most prominent characteristics you'll ever see when you're looking at these woods, especially petrified woods with the hand lens. So you can have solitary vessels. You can have vessels that are in multiples, radial multiples, or chains. They can be clustered together, or they can form wavy lines. So let's look at some of these examples here and see how these vessel types manifest themselves. So in this particular example, there are small vessels that are scattered. So that is an identifying characteristic. Here, there's small vessels that are all close together. There's a lot of them. And some of these you can see there's little chains of them. There's multiples, they call them, several of them together. This one down here, this is large vessels all clustered at the growth ring boundary like we saw in the previous example. And then the late wood pores, vessels, are clusters. They're clustered together, which is a little different than the one we saw before. Here you have chains or groupings of vessels in a radial fashion. And then in here, you have the last type. It's called wavy bands, and these are wavy bands. Okay, and this is called ulmiform because the elm family is called ulmus. So it's an elm characteristic, and you can see that from right here.
Okay, now we have another specimen. In this one, right away, you can see it looks like a round trunk, very smooth on the outside. And so we need to figure out what this is. So as we move into it, we can look on the top of it, which has been conveniently cut for us to look at, and it's actually been polished there too.
And what you see here is the same thing that we saw in the previous specimen, and that is that the center of it is brown, and that's mineralization. It's also highly silicified, so it polishes well. And then over here we have holes, big wide holes from decomposition. And you can see minor decomposition here. This is all before the specimen was fossilized. So those are holes that kind of preserved in there. So the only other thing we see that's kind of a diagnostic feature is these circular bands, which now we know those are growth rings. But does that identify this? No, it doesn't. So let's start moving in close until we start to see some kind of cellular feature that can help us identify this thing. So as I move in, you can see here that there are some features there, and these just might help us identify what this is. So what we see, that's a growth ring, that's the next growth ring, and that's the previous growth ring. So okay, so we can see growth rings. In between those growth rings, you can see these lightish areas that look like they're dots, or they might be connected. A lot of them appear to be connected, and they form these lines, these sort of fat lines that wave. They're wavy lines. And so this is about the closest I can get to this. And you can see those wavy lines all through this. You can see them up there. You can see them over there. They're all through this. If I were to go around this piece, you'd see the same thing over and over and over. So that tells me that this is an elm, and it's exactly what we looked at in the previous picture of cellular features. Okay, so we've now discussed rays and vessels and the different ways they configure. Now we're going to go to the third cell type, and that's parenchyma cells. These are very key in making diagnostic interpretations or identifications of your fossil wood specimens. So let's go over these from left to right. First type is thin bands of parenchyma cells that extend between two rays. And you see examples of that here. I'm not going to show any examples of this type here in this presentation, but I can assure you that in the tropical trees that we have fossilized here in Texas, this is a very common feature. So I look for it all the time. The next is scattered parenchyma cells, and it's very difficult to see these under a 10x hand lens, and so we won't concentrate on those here. The third type is this grouping here, and this is all characterized by parenchyma cells that surround vessels. It's known as the centric parenchyma. There are various thickenings of this from one cell thick to very thick, and I see this all the time. And in fact, I'm going to show an example of this coming up right after this. So this is a very key characteristic here. And the final are bands of parenchyma. And these are common as well. So here, this example, it shows hickory. Hickory is a member of the walnut family, and we do have fossil walnut family members here in Texas. So I look for this characteristic and I find it, and when you find it, you pretty much know you have a walnut. So it's a very key characteristic. Okay, we're back again. And here I have two thick slabs. They're not really slabs, they're about 6 to 8 inches high. Two of them. One of them's black. Let's look at this black one first. So right away you can see prominent growth rings emanating from a center that's about right there. And those growth rings are pretty prominent. And this is from the coal fields, the lignite fields up in the north central Texas, by the way. And as we get closer and closer and closer to this, well, guess what? You've seen this before, folks.
It's the same thing happening again. This is one after another growth ring. It's about as close as I can get it, but you've seen this before, and so this is obviously a conifer. And as I said, this is from the coal fields up in north central Texas, the lignite mines that we have there. So this is a relative of the bald cypress from the Eocene. So here, let's start looking at our second one here. This is a nice golden brown color here. That's a very pretty specimen. And that nice red, that's all mineralization. So there was a hole right there, and the specimen had some mineralization around that, creating that red color. It's very pretty, actually. And the only thing we can see here is some faint growth rings that emanate from that area up there. So that's the center, and we have some growth rings, but nothing else really. So as we usually do, let's start getting closer and closer and closer until we can start seeing some cellular detail. And now we can start to pick out some things here. Yes, I think we can see some things. So you can see dots. Now we saw dots in the last specimen that we had too. So the question is, are those dots connected or not? And it might look like some of these are connected, but this is tough seeing. So if they're all connected in wavy lines, it would be an elm. And some of them look like they are, but not all of them look like they are. So this is going to call for us to do a little further investigation closer up. So now I bring out my handy dandy 10x hand lens, which is required equipment for anybody who goes out into the field. And let's see if we can play a little trick of nature here and see if we can zoom in to some of these spots and get it in focus. It's kind of tricky, but I can see some of these. Excuse me for the lights all shining in your eyes, but okay, so you see those? Those are some white spots, and they are not connected. They are individual white spots. Although in some places they look like they're starting to connect, but most of them are separate. Now here's some that look like they might connect. But we've already seen enough, actually, folks. We've already seen enough. So even if some of them connect, but most of them are separate, then that tells us that these are white spots and they surround vessels. And anytime you have white spots surrounding vessels, those white spots actually are parenchyma cells. Anytime you have that happening, then it's a legume. Legumes are very common in the fossil record of Texas, and actually they're a very large family, in fact. So this is a legume.
Well, I thank you for your attention, and I hope this educational video has been useful and has taught you some techniques to identify petrified woods that you find here in the state of Texas. And if you'd like to further investigate these principles, I use this book by Bruce Hoadley a lot. In fact, some of the illustrations that I've used in my presentation are from Bruce Hoadley's book. And he's a craftsman. He's a woodworker. So this is modern wood he talks about, but these principles apply to fossil woods as well. And if you have any questions, like me to clarify anything that I was talking about in this presentation, or would like to move to the next level of identifying fossil woods, please don't hesitate to contact me. In the meantime, have a nice day.